Hi everybody, back finally with a video about Boolean logic. And so what we're going to do is we're going to open and make a new class, Boolean practice. And we'll make our main method, and this is where we are going to get going. So, Boolean logic involves comparisons of values and sort of this special type of logical math on values to produce an answer that's either true or false. So we're just working with statements and conditions and ideas that we can either answer with a yes or a no, a true or a false, a 1 or a 0. Now in Java, the only answers are going to be true or false. Nothing else. Those are Boolean values. And from your data type, Boolean, we can have a Boolean data type be true or a Boolean data type be false. But we can't do something like 0 because it only holds the value true or false. Can't convert from int to Boolean. Now, I could do a cast of that nature. Well, cast doesn't work with this either. So we're sort of stuck with just the idea of the words true and false. And then we get no errors. So using this idea of true and false, well, what types of things can I say in programming? What types of things would be true or false? So let's think. Well, math is a pretty good example. If I say 3 is equal to 5, well, that has a definite truth value. So I'm looking at statements that have a truth value. Before I start, though, I'm going to think about some operators that can be used to compare values. Comparison is really the big deal here. So first, I'm going to compare using an equality operator, double equals, and this means is the left side equal in value to the right side. So, for example, three equals 5 is 3 equal to 5, that would be false, but 5 equals 5 is automatically, of course, true. So we can see that the equality operator compares the left and the right. And we also have relational operators. We have greater than, we have less than, we have greater than or equal to, we have less than or equal to, and we have not equal. So we have something to compare and see whether things are not equal. So an example here would be 3 is greater than 1. That would give us true. I'll change these to arrows just to sort of show what I'm working with. Here, 3 is less than 1 would be false. Here, again, 3 is greater than or equal to 3 might be true. And 3 is less than or equal to 4, or let's say 3 is less than or equal to 2, might be false. Then finally, 3 is not equal to 5. That statement would be true. And so now let's see how I can actually use this. I could store these in a Boolean value. I'll name it comparison, or a Boolean data type, a Boolean variable. Here we go. Let's say 3 is not equal to 5. Well, let's see if it really is true. I can print out that value. And I'll run this, and I get a printout that says true. If I say 3 is equal to 5 as a statement, what I get is false. And you'll notice I'm actually printing out this instead of my variable, which I should be doing. I can print out the variable, and you'll see again, true for this statement. But if I change the statement to be an equal sign there, I get false. So let's say I want to actually do some useful things with this. Well, I could print out something like this. I could do, oh man, we haven't talked about our other operators that we need to care about, our logical operators. So while I can do things here, and maybe use something called an if statement, which we'll get into more in the next episode. I'm just going to introduce the format here. If 5 is greater than 3, which we definitely know is the case, we can print out 5 is greater than 3. We'll run this and we can see it's the case, but if we write 2 is greater than 3, well, that's false, and we don't get a printed value. And this warns us against dead code. It means it'll never be reached because of this condition. So we'll look at if statements in the next video, but these are our comparison operators and our equality operators. Let's look at our relational operators. Let's look at our logical operators. We can use the word and, or we can use or. There are a couple other variables, or a couple other things that we can use here. Single bar, this is a bar. It's the shift backslash, the shift key, and then the button above the return. And this is shift 7, the ampersand. And these will let us join together a few of these statements. For instance, I can say that comparison is equal to 3 is less than 5 and 7 is greater than 2. Now, what's actually happening here? I'm looking at this value, and this value would give me true. 3 is less than 5. There's a yes to that answer, so I'd get true there. This 7 is greater than 2. That's true. Let's see what the AND operation does. Well, if we run this, we'll get true. Now, there we go. Just closing some consoles. Okay. So we run this and we get true. Whereas if I change this to, say, a greater than, well, 3 is not greater than 5, I'll run this and I get false. Now you'll notice there's a yellow line underneath this 7 is greater than 2. It's called dead code again. So what's happening? Well, if this is false, what an AND does is it says that both values must be true. Both the left and the right sides must be true to get a true result. The OR says any value can be true to get a true result. And so if we're looking at this, we say, okay, well, if this is false, it doesn't matter what this side is because my entire situation is going to be false. And says both values have to be true to get a true result. Well, I automatically know if this is false, the entire thing is false. So the program, Java, will not actually evaluate the second statement if the first statement is false. Which seems like a nice shortcut. But sometimes if you're doing something where you're modifying values after this, or you're doing some updating of databases or something like that, this can actually prevent that from executing. For instance, int x equals 5, I can say x plus plus greater than 3, and this is dead code. So normally, this would compare x to 3 and say, okay, well, 5 is greater than 3, that's true, and then it would increment x. So here I can print out the comparison, and then maybe I can also print out x, and I'll run it, and it'll show me 5. Whereas if I switch these two sides, and I'll reformat, well, x is greater than 3, well, that's true, because it's 5, and 3 is greater than 5, so this will not short circuit. This happens to be potentially true, potentially false, but let's see what we get out at the end. It's false because 3 is not greater than 5, but I still increment my value. And so the order here matters. This doesn't come into play with OR, because if anything is true, the value would end up being true. And no matter if I put x plus plus there or not, it will still evaluate, to some extent, both bits of information. The problem is the OR checks for true. And so if the first value is true, it's going to cut out because it doesn't need to worry about the second value. But if the OR statement is false, it'll suddenly look for the second value. One way around this is to use, well, really, just to make sure that you're evaluating things and you're not modifying things in a way that when you use and or, you get this short-circuiting effect. Okay, so this is the end of my discussion on Boolean values. I suggest you play around, see what values make what results, and what comparisons you can string together, how many of these you can string together, and really play around with it, because this is going to be the basis for a ton of work that you're going to be doing in the future.